So let's now talk about autonomous vehicles. The simple definition of autonomous vehicles is that vehicles that can drive themselves. They can sense their environment and drive themselves with little or no human input. And to do that, a variety of sensors are used. We can use radars, we can use lidars, ultrasonic sensors, sonars, etc. We also use inertial measurement units in autonomous vehicles, and they are also installed to pinpoint the exact location of the car within a quarter of an inch. Let's also talk about driver assistance vehicles. Well, these vehicles require constant input from the driver. Certain tasks like maintaining lanes can be taken over by the computer, but that too under very certain conditions. These vehicles are not equipped to deal with uncertainty in human behavior. And to elaborate on this point, we can take the example of a human being standing on the curb. The vehicle doesn't know, I would not be able to figure out what he or she wants to do, whether the human being or the pedestrian standing on the road likes to cross the road or not. So it is very difficult to quantify human behavior. It's still very useful though, and we are going to see a few examples of that later on in the slide. So what's the difference between autonomous vehicles and driver assistance vehicles? Driver assistance vehicles require constant input from the driver, whereas autonomous vehicles require little to no input from the vehicle, or the driver, sorry. Autonomous vehicles are equipped to handle uncertainty, which was not the case in self-driving or driver assistance vehicles. Autonomous vehicles aim at replacing the driver completely. Driver assistance vehicles aim to enhance the capability of the driver, and that is a major difference between the two. So, what are the levels of automation that we have been able to achieve? From what we have seen up until now in the previous two slides, we can clearly say that driver assistance vehicles come under the larger system of automated cars or driverless cars. So let's see what levels of automation we have. Currently, we have almost 6 levels of automation, and we are going to see them one by one. Level 0. All major actions are controlled by human beings. That is the driving cars that we have these days. Level 1, cruise control, automatic braking may be controlled by the car, and that too just one at a time. And elaborating on cruise control is a functionality that has been added in cars and vehicles these days, where if you are on a highway and you need to maintain a certain speed, the car takes over the steering and the acceleration part of it for you. But that too for a very limited period of time, and you have to keep your hands on the steering wheel, otherwise it gives you a warning. On level 2 of automation, there are two functions that are controlled at a time by the car. So we are going one step up, like steering and acceleration. Level 3 is all safety critical functions managed by the car under certain conditions, but driver is still expected to take over when alerted. So there would be some sort of mechanism that would alert the driver for impending emergencies. Level 4, the car is completely autonomous in certain scenarios, not all though. So in level 4 cars, you can see that the car can take over all the functions of the car, but in certain scenarios, the driver would still be expected to take over when alerted. And level 5 is the car is completely capable of self-driving in every situation, be it on a highway, be it on if you have to park your car, if you have to navigate through serpentine lanes, if you have to park the car, all those scenarios should be taken care of by the systems that have been installed on the car for automation. Let's see a few advantages of self-driving cars. Well, as has been the scope of this presentation so far, we can pretty much see the broader picture of the advantages of self-driving car. Well, we can see that with respect to automated highway systems, it eliminates the human error element of driving. Self-driving cars would not have any drivers, so no more drunk driving, no more breaking of the rules. That's pretty evident from the word self-driving cars itself. Let's get a little more deeper than that. Self-driving cars would make getting lost a thing of the past. For example, because from going from point A to point B, you just need to input the coordinates where you want to go, and the car would take care of the path it wants to take. And that can depend on several factors like availability of road and what all information is flowing in it. And we're going to we're going to see a little bit about that as well in the next couple of slides. Long overnight journeys would become more comfortable. That's pretty evident. No need for controls, therefore more space for passengers. And this is actually pretty significant, not just because it would increase the capacity of the car, but it would also help in improving fuel efficiencies. And for people who are into carpooling, this would make pretty much more sense. Sensors would be used to sense the environment outside the car. So therefore, in cases of snow, fog, heavy rain, climatic conditions where human beings are not able to see as they should be, the car would actually perform better than a human being. Rules. Since these self-driving cars would be functioning on strict programming laws, rules of the road would not be broken. So no more drunk driving, no more breaking of red lights, running the red lights, no more overspeeding. Nothing of that sort would happen. Those problems would be eliminated right away. Elderly, disabled, and children, and other groups of people who would otherwise need some sort of assistance for mobility would be free to move around. And this actually would have not just the comfortable part of it, but it would also contribute to the economics of it. And these people who are actually dependent on somebody else to get their job done would now be able to roam around freely. Navigating through suburban lanes and parking in tight spots would become a lot easier, and this is pretty evident as well. Driver license and driver's test would become obsolete, so that would be delightful for people who do not who are bad drivers. That would come in as a relief. What are the disadvantages of driverless cars? So far up till now we have seen the advantages. Let's take a look at the disadvantages of them as well. Let's weigh the good and the bad. Driverless cars would be expensive and not everybody would be able to afford them. This is pretty evident, and let me give you an example of that. The two major players in driverless cars today are Google and Tesla. And they have pretty much very varied approaches to the driverless car project that they have taken. Google relies heavily on the LiDAR system. And in 2009, when they started their driverless autonomous car project, they were buying LiDARs from a third-party system, from a third party. Somebody else was manufacturing them. And at that point of time, LiDARs were costing them $75,000 per LiDAR. One LiDAR was costing them $75,000. From then to now, although Google has been able to drop the prices from $75,000 to $7,500 per LiDAR system, since now they have started manufacturing them on their own, it is still a huge overhead. It's not cheap. As has been the trend in history, automation always results in loss of jobs. Truck drivers, taxi drivers will lose their jobs, and that too instantly. Information would be constantly flowing between cars and other information interchanges systems. This would result in some privacy concern. As soon as you hook up something with the advent of uh, IoT way of life, this has been a major system, and this is a pretty obvious concern that people who would be people who are designing driverless cars have. Um, we would also need to have some new laws and new judicial reforms for driverless cars on the roads. For example, if there is an accident on the road, then whose fault is it? Because in case of driverless cars, the human element is already gone. Human driver element, uh, is already gone. So who do you blame then? The team that developed the software, or the team that developed the hardware? Or is it the person who got hit himself, who should have known better not to jump in front of a driverless cars? So that would result in some moral debates as well. Autonomous cars have difficulty in predicting human intention. This could result in disastrous results. We have talked about this earlier as well. Since the driverless cars follow all the rules of the road, if these cars are put to use with vehicles driven with humans, they would be stuck in a no-win situation. For example, assume that we are standing on a intersection, cross section, and there are some driverless cars and there are some cars that are driven by human beings. So human beings have a tendency to break laws sometimes. On the other hand, driverless cars would follow all the rules of the road because they are based on a solid programming system. So in that situation, if all the other human being driven cars are crossing every now and then, not following the rules, in that case, a driverless car would be stuck in a no-win situation. It would just stand there. It would not move. Well, driverless cars would be connected to the internet, and with this comes the possibility of getting hacked. That is pretty obvious. Uh, Another moral dilemma is that it is very difficult to. Another problem is it's very difficult to program for moral dilemmas. And what I mean by that is that the programmer who is designing, who is writing the code, what should his approach be? Should he always be programming the car to facilitate the safety of the passenger? For example, let's take a case. If the car is going down the road and it has to choose between plowing through a crowd of children or driving off the bridge, what should it do? So that sort of model dilemmas are also there that need to be addressed. Now let's take a look at some popular technologies in driverless and autonomous cars. Waymo, name of the technology that is used by Google for their self-driving car. LiDAR, which stands for light detection and ranging. Radars are used to draw a detailed map of how far the object are, what the environment is around the car. High resolution cameras are also used to detect visual information like traffic signal and their state detection, whether it is red, green, or orange. This LiDAR can draw a 360-degree view of the map around the car, and the range is up to 3 football fields per hour, and that's pretty good. So this is a Fiat Chrysler car that Google is using, and as we can see that here, as where my mouse arrow is pointing, this hood sort of thing, that's the LiDAR system that is installed, and there are radars on the back end of the car to detect snow, rain, fog, etc. And Waymo's self-driving sensors are tightly integrated into the hybrid minivan created by Fiat Chrysler. And there are also 8 forward-facing cameras that work with others stationed around the car to provide a 360-degree vision. Let's talk about it, Google's main opponent, Tesla, and what is its approach. In one of the recent automation events held by Tesla, CEO of Tesla, Mr. Elon Musk, said that LiDAR is a fool's errand, and anybody who's trying to solve the driverless car problem with it is running around in circles. And the reason that he gave for his such harsh view on LiDAR was because, in his opinion, as soon as you solve the visual aspect of the problem, LiDAR completely becomes an extensive and useless overhead. In his opinion, if you can solve the visual aspect by cameras, why are you using LiDARs? Although he's not against LiDARs, in his own company he's using LiDARs in his SpaceX program. But as far as Mr. Elon Musk goes, his LiDAR is an expensive overhead that can be done away with. So what does Tesla use then? Well, Tesla uses 8 cameras, 1 radar, and 12 ultrasonic sensors to get the job done. Out of these 8 cameras, three are front facing, 2 are on each side, and 1 in the back. There is also one front facing radar at the bottom. So this is actually what the Tesla sees. So as you can see where my mouse is pointing at this blue dot, here are the 3 front facing cameras and it is inside the windshield. And these green circles, these green views lines give us a side view on the left side of the car, similarly on the right hand side, and then there is this purple highlighted area is the rear view camera. And these yellow dots, as we see, these are the ultrasonic sensors that are placed here. And right here in the front, where this blue zone is, there is the front-facing radar that is placed. Now, if we want to take a look at the lidar and radar on a radar map, on the left-hand side we have the lidar, and we can see that we have a pretty good scale of lidar when it works in dark. It works in bright. It works reasonably well on resolution and its range is pretty good as well. But it scores very poorly on proximity detection. Sensor cost is, as we have discussed, is pretty very high. So uh, it's very bad in that area. Sensor size is way too much. So that's one of the major concerns as well because it's not very aerodynamic. It can detect speeds at good. That's a point in favor of lidar. It does not provide any color or contrast, so that it provides it's very bad in that department. Works in snow and fog. Yeah, we can, and that's reasonable. But as far as we move on to the Tesla system, which uses cameras, radars, and ultrasonic sensors, we see that it is much better in all the departments. The only area where it lacks and it's not good is color and contrast department. No, actually it does. It does pretty well in that area as well. So not only cameras, radars, and ultrasonic sensor are cheaper and they perform better in this area. Yeah, they're much better than LiDAR's usability in these case. So as far as we have seen, what are the we have seen driver assistance vehicles and driverless cars as well, but there has been more improvement in driver assistance vehicles rather than in complete autonomous cars. And so let's see what are the 3 main challenges there are. And firstly, we need to develop a safe system, and for that, as we have pointed out in the disadvantages of driverless cars, we need to be able to quantify what is safe. How do you quantify safe? What is safe and what is not safe? So you need to incorporate human dilemmas. You need to figure out um, how to quantify human dilemmas and various other factors as well. To support this safe system, we also need to develop hardware and develop hardware capabilities to support the system. When we take a look at Tesla, just a couple of years back, they had a processor that was able to uh, process only 100 images per second, but now they have been able to manufacture a custom-made chip that can run the neural network on which this new hardware system would be able to run, and that can process up to 2100 frames per second, images per second. So that's a huge jump, but still we need to go further than that. And lastly, the most important problem is to program for practicality and safety. We cannot do both because when we talk about safety and driving, we need to understand that driving is inherently a dangerous situation. So the safest possible way to drive would be to not drive at all. So we need to find that sweet spot between the practicality and safety aspect of driving, and we need to be able to quantify these things which we have never done before. So and these things can change from person to person. So we need to take a look at that as well. Since we are talking about automated highway systems, let's talk about connected vehicles and their relation to automated vehicles. Well, connected vehicles also provide the driver with a 360-degree awareness to the driver of the car. Drivers would get information about potential hazards through visual display, seat vibrations, or tone. The driver would always be in charge of the vehicle. Drivers would be assisted by a slew of driver assistant applications. So we can see that in connected vehicles we are not uh, we are not putting too much emphasis on making the car completely driverless. Instead, what we are trying to do is help the driver a little better. We are trying to give him a better view of the environment that's around the car by still keeping the driver in charge of driving. So we can just skip past those moral dilemmas and all those uh, judicial reforms that we were talking about. What are some examples of driver assistance applications? Let's take a look at them as well. Well, intersection assist application. This is pretty obvious. If you are trying to cross an intersection, this application would alert the driver and let them know when it's the safest possible time to cross the intersection. Do not pass a slow vehicle application. Sometimes when you see when you're driving on a highway and there is a huge vehicle, tractor or trolley dumper that's moving in front of you, and you cannot see what's in front of you, since the two cars would be the two vehicles would be connected to each other. Even though you cannot physically see what's coming from the other side of the road, this connectivity would be able to give you a better awareness about the environment and would let you know when you can pass that vehicle. Another application is emergency electronic brake light warning. Uh, Imagine a situation where you're driving on a highway and let's say 20 cars ahead, you cannot see what's happening 20 cars ahead, and some car starts to break down. And since there is a connectivity between all the cars, each car would be forewarned about this random vehicle that is braking in an emergency situation. So all the cars would be able to slow their rates, slow their speeds, and those horrible crashes that we have on highways during fogs and whatnot, where several cars rear end each other. That situation can be avoided. Blind spot warning. For example, the example of this can be, imagine you are a truck driver and you cannot see what's happening on the rear end of your truck. So if a biker is coming, or if your car is trying to overtake you, it would immediately warn the driver of the truck, and both it would help both the vehicle that is trying to pass and the truck driver as well. Rail cross violation warning. It's pretty evident from its name what it wants to do. Road weather motorist warning application. So what is this? There are certain scenarios in which the weather may not be as bad as it looks, but it has a very adverse effect on the driving conditions. For example, in heavy rains, the road becomes slippery, or in places and cases where there is temperature drops down quite low, but it's not low enough to fog or either make to snow. But there is a phenomena called black ice, which is ice that's on the road, and it becomes very difficult to ride at that point of time. So it's especially during nights, it's very difficult to detect. So that app would be helpful there. Information collected from drivers, real-time information that is collected from the drivers and AHS, can be sent to information centers from where they could be broadcast for the help of other drivers as well, who are either on the roads or still at home preparing their journeys. What are some advantages of connected vehicles? One of the biggest uh, advantage of connected vehicles is eco lanes. They are very similar to today's HOV lanes and help in conserving fuel. So what are these eco lanes? Eco lanes are similar to these HOV lanes where a lot of cars in tight formation decide to move in on a particular speed in the most fuel conserving manner, and they would move in a green corridor. So our problem of initial problem of too much global warming and fuel consumption would be solved through these. Definitely would reduce accidents as we have seen from the examples that we have been getting. Since these cars would be connected to each other and would be so to say talking to each other, for lack of a better term, these would be able to give the drivers a lot of reaction time. Real-time data would be sent to your tablet, mobile. This could help in choosing the most appropriate route for the vehicle. Even if you don't have a personal vehicle and if you're connected to the AHS system, you could get updates or you could update the driver regarding your status. Say, for example, if you're traveling from point A to point B, but you're not traveling from point A to point B in a uniform fashion, you are changing vehicles or you are taking a train and you want to catch another train. This connected vehicles can help us in that direction as well. How do we achieve connectivity? So this connectivity can be achieved through DSRC, which stands for Dedicated Short Range Communication. It's actually the technology behind the connected vehicle systems. FCC in 1999, actually, FCC is Federal Communication Commission, authorized 75 megahertz of spectrum between 5.850 to 5.925 gigahertz for DSRC. It's short-range to medium-range communication system and aims at replacing 802.11 IEEE protocol, which is essentially the Wi-Fi technology. So we don't need to get into too much detail for that as well. And this is the DSRC infrastructure. As we can see in the top left-hand corner, we have the GPS antenna, which will be connected to the information center. And on the right-hand side is the DSRC antenna. This GPS antenna would feed information to the GPS and it would be communicating with DSRC radio on either way. This DSRC would be connected to the computer that's on the vehicle, and this computer would then be able to uh, this would get information from the sensors and it would also give information to the sensors, and then this information would be displayed on driver interface. We also need to understand this that driver interface is necessarily not a visual interface. It could be audio interface as well. This is a layout of DSRC spectrum and standards. We can see that it's IPv6, TCP or UDP. We can use either of those services. Non-safety applications, there can be message dictionary, SAE, J2735. Minimum reference requirements, DSRC upper MAC layer and physical layer and MAC layer as well. And on the left hand side we have the a spectrum, and as we can see the frequency each has a 10 megahertz band, and high power public safety is on the right hand side. Service advertisement and broadcast, which would be given to everybody, is in the middle control channel. And critical safety of life, max power 20 dBm, 200 milliwave, milliwatt, that's on the left hand side of it. So it's pretty self-explanatory. What are the challenges in the implementation of AHS? The biggest challenge is the implementation of technology. AHS requires dedicated lanes, huge investment is required. Not everybody would be able to afford vehicle equipped with automation technology. Entry and exit points for automated vehicles will be needed, which may result in choke points. Major urban design challenges for mixing of automated and non-automated traffic. Building new roads and adding rights of ways will be problematic in urban areas. So if we see this entire thing from the perspective of a system engineer, it would at least consist of two subsystems, the vehicle and the infrastructure, and vehicle would actually be moving on the edges. Vehicles would further be subdivided into multiple subsystems, sensors, data processing, image processing, actuators, communications, equipment, etc. EHS will have several subcomponents as well. EHS entry, exit, object detection, collision warning avoidance, longitudinal and lateral vehicle control, navigation, etc. So what are the summaries and lesson learned? We have seen that the traffic has grown exponentially. Several problems have arisen out of it: effective mobility, pollution, accident incidents, you name it. And we have seen that the traditional methods of solving these problems are not enough. We can't just keep increasing lanes to solve this problem to maximize our traffic on the road. So we need to find innovative solutions to these problems, either from existing technology or we have to invent new technology. As we have seen in the case of Google and Tesla, Google is trying to invent a new technology in the form of LiDAR, whereas Tesla is still banking upon older technology, and because it also aligns with the mantra of the company that they have to provide affordable vehicles, whereas LiDAR is not that affordable at current point of time. It may be able to Google may be able to find solutions to that as well. And in fact, as far as my opinion is concerned, I am pretty happy that both these companies are working in two different, completely different directions, because it's now then because they are both now pushing each other to the finish line, which would be very effective and beneficial for the end users. Uh, these are just this is just a small part of the solution that we are trying to achieve. The autonomous cars or driverless cars or automated highway system in general as well. The bigger picture here is the ITS, intelligent transport systems, and AHS, connected vehicles, autonomous vehicle, driver assistance vehicles, all come under this umbrella, and we have to work on all of these. Thank you.